Hello! In the rectangular coordinate system, each point is represented by two coordinates, x and y. The x-coordinate tells us how many units we move left or right, and the y-coordinate how many units we move up or down. In the polar coordinate system, each point is also represented by two coordinates, and these are r and theta. R is the directed distance from the pole, and theta is the angle generated by a rotation from the polar axis. Converting rectangular coordinates to polar is not as simple as converting polar to rectangular. First, we must remember that if in the rectangular coordinate system each point has only one representation, in the polar coordinate system each point has infinitely many representations. To keep it simple, when we will convert to polar, we will keep r positive and theta an angle between 0 and 360 degrees. Now, in this figure, we have the polar axis along the positive x-axis. Then, using this right triangle, we can form two important equations that will allow us to convert from rectangular to polar. The first one, using the Pythagorean theorem, we can write that x squared plus y squared equals the hypotenuse r squared. So again, x squared plus y squared equals r squared. Then if we want to solve for r and keep r positive, then r equals square root of x squared plus y squared. So knowing x and y, we can use this formula to find r. Another relation that uses x and y, as well as angle theta, is the tangent function. By definition, tangent of angle theta equals the opposite side y divided by the adjacent side x. So tangent of angle theta equals y over x. Then theta equals inverse tangent of y over x. So this formula will give us angle theta, however, it has to be adjusted depending on the quadrant. Now let's see the steps we have to take to convert rectangular to polar. So here we have the steps, and in step 1, we will plot the point with the coordinates x and y. By plotting the point, we will be able to clearly see the quadrant in which the point is located. In step 2, we will find r using the formula square root of x squared plus y squared. This formula will give us a positive value for r. In step 3, we will find angle theta using the formula inverse tangent of y over x, then we will adjust it based on the corresponding quadrant. Recall that we want theta to be an angle that is greater or equal to 0 and less than 2 pi, which is 360 degrees. If the point is in quadrant 1, then to find theta, we just use the formula inverse tangent of y over x. If the point is in quadrant 2 or in quadrant 3, then theta equals inverse tangent of y over x plus pi, which is 180 degrees. In the following examples, I will explain in detail why we need to add pi. And now, in quadrant 4, theta equals inverse tangent of y over x plus 2 pi, which is 360 degrees. Now, let's see the first example. Here we will convert the rectangular coordinates square root of 3 and 1 to polar coordinates. In step 1, we will plot the point. And for this, we will draw the rectangular coordinate system. Then square root of 3 is approximately 1.7, so from the origin we will move 1.7 to the right and then 1 up. So here is the point, and we can clearly see that this point is in quadrant 1. Now in step 2, we will find r. The formula is r equals square root of x squared plus y squared. In this formula, we will replace x with square root of 3, so we will have square root of 3 squared, and y with 1. Then square root of 3 squared is 3, and 1 squared is 1. Then 3 plus 1 is 4, and square root of 4 is 2. And now in step 3, we will find angle theta. The formula is theta equals inverse tangent of y over x. Then in this formula, we will replace y with 1 and x with square root of 3. And for simplicity, we will use degrees instead of radians. Then if we use a calculator or the unit circle, we will get that theta is 30 degrees. So then, the polar coordinates r and theta are 2 and 30 degrees. Now, let's see another example. Here we have a point with the coordinates -2 and 2, and we will start by plotting the point. And for this, we will move 2 units to the left and 2 units up. And here we see that this point is in quadrant 2. Now, in step 2, we will find r. r equals square root of -2 squared plus 2 squared. Then r equals square root of 4 plus 4, and this makes square root of 8. Then to simplify, we will write 8 as a product of 4 times 2. And if we take square root of 4, then r equals 2 square root of 2. Now let's find angle theta. In quadrant 2, the formula is inverse tangent of y over x plus 180 degrees. So to find angle theta, we take the inverse tangent of 2 over -2 and we add 180 degrees. We can also write this as inverse tangent of -1 plus 180 degrees. And now here, let's discuss why we have to add 180 degrees. This is because of the range restriction of the inverse tangent function. When using a calculator to find an angle with the inverse tangent function, the result will always be an angle between -π/2 and +π/2, which is -90 degrees and +90 degrees. But an angle whose terminal side is in quadrant 2 is more than 90 degrees, and it will not be directly displayed by the calculator. In quadrant 2, tangent is negative, and it is also negative in quadrant 4. To understand what angle the calculator will display, I will connect this point with the origin and I will extend it into the opposite direction. We need to find this angle. However, the calculator will display a negative angle in quadrant 4. So if we use a calculator to find the inverse tangent of -1, we will get -45 degrees. Then to get this angle, from -45 degrees, we need to add 180 degrees. So then theta equals -45 degrees plus 180 degrees, then theta equals 135 degrees. So this is an obtuse angle and it measures 135 degrees. Then the polar coordinates r and theta are 2 square root of 2 and 135 degrees. Now let's see the next example. Here the point has the coordinates -square root of 3 over 2 and negative 1/2. We will start by plotting the point. Negative square root of 3 over 2 is approximately negative 0.9. So we will move approximately 0.9 to the left and then 1/2 down. And here we see that this point is in quadrant 3. Now let's find r. r equals square root of negative square root of 3 over 2 squared plus negative 1/2 squared. Then square root of 3 squared is 3, 2 squared is 4, plus 1 squared is 1, and 2 squared is 4. Then 3 over 4 plus 1 over 4 is 4 over 4, which makes 1, and square root of 1 equals 1. And now let's find angle theta. In quadrant 3, the formula is again inverse tangent of y over x plus 180 degrees. So we will write that theta equals inverse tangent of negative 1/2 over negative square root of 3 over 2. And all this plus 180 degrees. Then negative divided by negative is positive. 2 and 2 will cancel, and we will have 1 over square root of 3. So theta equals inverse tangent of 1 over square root of 3 plus 180 degrees. And again, we are adding 180 degrees because of the range restriction of the inverse tangent function. And again, this range is an angle between negative 90 degrees and positive 90 degrees. However, if we connect this point with the origin, then the angle formed is more than 180 degrees. The tangent in quadrant 3 is positive, but so is in quadrant 1. So when we evaluate the inverse tangent of square root of 3, instead of displaying an angle in quadrant 3, the calculator will display an angle in quadrant 1. So if we use a calculator to find the inverse tangent of 1 over square root of 3, we will get 30 degrees, which is an angle in quadrant 1. Then if we have this angle in quadrant 1, to get the angle in quadrant 3, we have to add 180 degrees. So then theta equals 30 degrees plus 180 degrees, and this equals 210 degrees. So the polar coordinates r and theta are 1 and 210 degrees. And now let's see one more example with the point in quadrant 4. So here we have a point with the coordinates 4 and negative 4 square root of 3. We will start by plotting the point. So here we have the rectangular coordinate system, and we will move 4 units to the right and approximately 6.9 units down. This point is in quadrant 4. Now in the next step, we will find r. r equals square root of 4 squared plus negative 4 square root of 3 squared. Then 4 squared is 16. Then negative 4 squared is also 16, and square root of 3 squared is 3. So we will have 16 times 3, and 16 times 3 is 48, and 48 plus 16 is 64. And square root of 64 is 8. Next, we will find angle theta. In quadrant 4, the formula is inverse tangent of y over x plus 360 degrees. So we will write that theta equals inverse tangent of negative 4 square root of 3 over 4 plus 360 60 degrees. Then 4 and 4 will cancel, and we will write that theta equals inverse tangent of negative square root of 3 plus 360 degrees. And now, before we continue with the calculations, let's discuss why we have to add 360 degrees. And again, this is because of the range restriction of the inverse tangent function. If I connect this point with the origin, and if we want angle theta to be a positive angle between 0 and 360 degrees, then this will be the angle formed. However, because of the range restriction, in quadrant 4, the calculator will display a negative angle. So if we use the calculator to find the inverse tangent of negative square root of 3, we will get negative 60 degrees. And this is this angle. But to find this angle, we need to take negative 60 degrees and add 360. So theta equals negative 60 degrees plus 360 degrees, and theta is 300 degrees. So then the polar coordinates r and theta are 8 and 300 degrees. Thank you for watching the video. Please give me a like, write a comment, and subscribe to the channel.